Here's an example for how you estimate it, and I'm not going to spend very much time on it. Again, we have a bunch of documents. The big difference now is nobody's telling us which documents are relevant and which ones are non-relevant, so we have the entire collection. That's our vocabulary. You count how many times, in how many documents each word occurs, right? Again, so you discount repetitions. So B occurs in every document and it occurs multiple times, but we still only count it once. That's our probability, so that's our RDF, that's our QW over 1 minus QW, 1 minus QW over QW. Right, so you just take NW for the word A, that's 2, we add a half to it, so that's 2.5, and then N minus 2 is going to be 4, we add a half to it, we get a 4.5. And the way you use it is query comes along, let's say the query is ACH, so what you can then do is you can then compute the posterior, or it's really a misnomer to call it that, but if those if you take those assumptions at face value, then you're still computing the posterior probability of relevance. So the posterior probability of relevance for document 1 is the product over the intersection of the query and document 1, right? So document 1 has words A, B, C, B, D, this has ACH, so we only take the words A and C, because none of the other words are in the intersection, and for those words, for A and C, we compute that quantity and we multiply them together, right? So for the word A, we get 4.5 over 2.5, right? And for the word C, it should be, 4.5 over 2.5. So we multiply them together, we get some sort of a number. Then we can repeat that for every document in the collection, right? So for D2, we're going to take an intersection of D2 in the query, and that's going to be the empty set, right? So the posterior probability of relevance for D2 is going to be 1, because our product goes over the empty set. For D3, it's only going to be term C, so it's going to be 4.5 over 2.5, and then for all the other documents it's going to look like that. So we get those scores. All of the other documents have exactly one word in common with the query, so it's very easy to compute that. And then once you've computed those probabilities of relevance, you would rank the documents based on them, and you would come out with the following ranking. So the highest ranking document would be D6, right? And if you're trying to get a sense for how do you rank documents without actually going through the computation, so in most of these cases, it's a single word that the document shares with a query, and so it's really the and what you're ranking by is the sum of the IDF values, or a product of these ratios. So if it's a single word, then the word with the biggest ratio is going to come out to the top, and the word with the biggest ratio is by definition the rarest word. So if you have some word that doesn't occur anywhere, that's going to be a big word, right? So so our query had the word H. So any document that contains the word H is going to be up there at the top of the ranking, and that's document 6, right? So it comes up at the top. So you can quickly get the intuition for which documents are going to be where in the ranking without actually computing these values.